Hello, everybody. Let's start our part two lesson in the polarity of molecules based on structure. Yesterday, we are done with the familiarization on the Lewis stats in assigning different valence electrons for a certain element, right? For instance, kung natay hydrogen, it belongs to group 1, then your hydrogen has one valence electron. Okay. So in terms of binding of nonmetals, some molecules exists because of covalent band. And the band between um, and among nonmetals that shares electrons. It could be polar covalent band or non-polar covalent band. However, molecular structures, shapes, electrons, and electron affinity are some consideration in determining the polarity of a molecule. So pila daw to. One is molecular structure, the shapes, and electron affinity. Further, a covalent band which creates two opposite poles, that is dipole, and results to positive and negative charges. Um, that is due to unequal sharing of electrons, is therefore called as the polar covalent band. Typically, example for this is the water molecule. Water molecule is also considered as polar covalent band. As shown below in this illustration, um, it is partially positive and partially negative pole due to the unequal sharing of electrons. Okay. Let's continue. So, kung atong ma-remember, no, pila ganitong electronegativity sa hydrogen. Pila ganito, it's 2.1. And for oxygen, we have 3.5. Okay? So what happens right now is, kung atuan ni siya butangan o um, EN values of 3.5, okay? A while, let's write the EN values here. It's 3.5, and your hydrogen has 2.1, and over here it's also 2.1. Then um, your hydrogen is being pulled by um, the oxygen. Since your oxygen is most electronegative. So kung taas ang value na ito sa EN values, don't forget it, naatay um, partially negative. Kung lesser ang EN values, it should be partially positive. So this pole is slightly negative, and this one is slightly positive pole. So now, the separation of charges makes the bond polar. Then it creates an electric dipole. Once we say dipole, it refers to two poles, one with positive and another one with negative, opposite poles within a molecule. And therefore, elements with higher EN values become partially negative, while elements with lower En values will become partially positive poles, right? And right, in this example, hydrogen has a positive molecules and are attracted towards the atom with higher electronegativity values, which is oxygen. No, that's um, an ion charge, thus making it structurally asymmetrical. On the other hand, equal sharing of electrons that distributes charges evenly and cancel these charges out happens in nonpolar covalent band and therefore produces nonpolar molecules. So, would there be electrical poles to come out in the nonpolar molecules? Of course, none. We cannot expect positive and negative charges if shared electrons are equal in number and in charges. This results to completely symmetrical structure molecule. In fact, in terms of atmospheric gases like nitrogen, oxygen, hydrogen, and halogens such as fluorine, chlorine, bromine are present in the air as a nonpolar molecules. These are diatomic molecule produced by the nonpolar covalent bond. Once we say diatomic molecule, um, these two atom, uh, again, no, once we say diatomic molecule, it is an atom that is composed of um, two molecules in an element. It is known as the atomic molecule because two atoms of the same kind combine and is nonpolar covalent band because there is equal sharing of electrons. Others could be polyatomic for having more than two atoms of the same kind bonded covalently. Liquid hydrocarbons, noble gases, and most organic molecules are nonpolar molecules. As a result, a polar molecule attracts another polar molecule and can get along pretty well together. Though water is considered a universal solvent, not all materials can totally dissolve it. Thus, if anything cannot be. So let's proceed. So again, this time we have liquid hydrocarbons, noble gases, and most organic molecules are nonpolar molecules. And as a result, polar molecules attract another polar molecule and can get along pretty well together. Though water is considered universal solvent, not all materials can totally dissolve in it. Thus, if anything cannot blend and mix well with water, it is definitely a non-polar molecule and is therefore categorized as hydrophobic molecule. Otherwise, if it is water-loving and if it blends well with water, so siya? It is known as hydrophilic. Simply put like this, like dissolves like, okay? Or hydrophilic. So there are differences between polar and non-polar molecule. Number one, polar molecules have positive and negative ends, or that is charges, while non-polar molecules charges are canceled out. Number two, in polar molecules, charges is unevenly distributed, while in nonpolar molecules, distribution of electron is equal and are completely symmetrical. Number three, when a highly electronegative atom band with less electronegative atom, a polar molecule is formed. Number four, nonpolar are mostly hydrocarbons, liquids. And number five, polar molecules have electrical dipole movement, while nonpolar don't have. Number six, polar molecules interact with polar molecules, while nonpolar molecules do not interact in the same way. And number seven, polar molecules have a lone pair on the central atom, while nonpolar molecules don't have lone pair in the central atom. Okay? So for example, we have here um, NH3 no, or ammonia. So kung atong tanaw na siya'y non-bonding electron pair. So automatically, once we see this, sa daw ang iyon, it is known as polar. Number eight, when an atom on the terminal is different, then it is polar. Number nine, like dissolves like, which means that polar molecules dissolves into other polar molecule and non-polar into other non-polar. Therefore, polar cannot um, dissolve into non-polar molecules and vice versa. Si non-polar, dili po siya ma-dissolve ni polar molecules. Okay, so it looks pretty much overwhelming, right? So let us simplify and choose molecular structures as basis for us check molecular property or its polarity. So which of the above description do you think can help us through with this? Is it item in from items 1 up to 9? Most likely, items 7 and 8 are sure keys to distinguish polar and non-polar molecules based on structures. So number 7, pag nylon pairs, it's polar. And kung ang atom ko no in the terminal is different, um, that is still polar. So now, if any of these two are present, either having lone pair on the central atom or when atoms on the terminals are different, then the molecule is said to be polar. Otherwise, it is considered non-polar for having any of those two. So this leads us to recall the previous lesson on Lewis-Stott structure of molecules. And if you happen to have forgotten this topic, here is a quick review that could bridge you to the main topic today. So this is our Lewis-Stott structure or LDS. A Lewis-Dot diagram or Lewis structure is a diagram of the valence electrons of an atom that uses dots around the symbol of the element. The number of dots equals the number of valence electrons in an atom. For instance, we have here lithium. Your lithium belongs to group 1. Therefore, it has 1 valence electron. Your boron belongs to group 2. So it has 2 valence electron, or beryllium rather. Your boron belongs to group 3. That's why it has 3 valence electron. Your carbon belongs to group 4, that's why it has 4 valence electron. Nitrogen is 5 valence electrons since it belongs to group 5. Oxygen belongs to group 6. Fluorine belongs to group 7, while neon belongs to group 8. And so, atoms tend to form covalent bonds to follow the octet rule, with every atom surrounded by 8 electrons. The apparent number of electrons for an atom to become stable. So we have here your NH3. So we started from writing its dots. No? For hydrogen, it's 1. And for nitrogen, it's 5 since it belongs to group 5. Therefore, to make the electrons become stable, we will now um, follow the octet rules. It will now be shared with nitrogen to hydrogen, right? And we have remaining one lone pair, right? We also have here the example of your water. No, I have already shown this to you yesterday. Bonding pairs are the same shared pairs of electrons represented by lines in the structure, while lone pairs or non-bonding pairs are the unshared pairs of electrons. Again, sa itong bonding pairs, these are lines in the structure or pairs of electrons. So we have here the Lewis dot of your oxygen and nitrogen. Okay, so from 6 dots or 6 valence electrons plus another 6 valence electrons um, resulted to this product. So there are 2 bonds available for oxygen, while for nitrogen is that type 3 bonding. So let us now consider this. There are types of chemical bonds according to the number of bonds. One is single bond. It has 1 pair of electrons. Double bond has 2 pairs of electrons. And triple bonds, 3 pairs of electrons. Valence electrons or electrons found at the outermost electron shell of an atom is known as your valence electron. It is also indicated by the group number of the periodic table. So be guided with the following in terms of creating the simple Lewis dot structures. We count the total number of valence electrons in the molecule. Example, NH3 has a total of 8 valence electrons. No? So 1 times 5 and then 3 times 1. So 5 plus 3, it's 8 valence electrons. Number 2, we use the formula of molecules as shown. No? So that AX sub N. You place the atom with the least number of valence electrons at the center of the structure. And number 3, you draw a single band from each terminal atom to the central atom. Number 4, each atom must contain 8 electrons to follow the octet rule. Note, place the lone pairs on the side and place any remaining valence electron on the central atom. Hence, if an atom still does not have an octet number, move a lone pair from the inside atom and the central atom to make a double or triple bond. So let's have some exercises. We have here the first element, no? CH4 or methane. So kindly identify the total number of valence electrons. So pila ato ang number of atoms present for hydrogen? Yeah, it's 4. So we use here 4 atoms. Okay, times 1 resulted to 4 valence electrons. So 4 plus 4, it's 8. So na kay 1 atom for carbon and you multiply it to um, the groupings, no? Since carbon belongs to group 4, so natay 4 valence electrons. So if we will represent this in form of Lewis dot, so this is our first illustration, and then this is our final answer. So the terminal atoms are all the same. The structure is symmetrical. Wala siya lone pair, and the polarity is it's non-polar. Ay pila ganito ang ato ang electronegativity sa carbon. Carbon has 2.5. Minatay 2.5. Okay, carbon has 2.5 and your hydrogen has 2.1. Okay. Let's have another example for water. Okay, your oxygen, it has one atom, and then you simply substitute it with 6. Okay, so we write here 6 for a while. So dili pasulat. I will just write it manually. So this is 6. Okay, so 1 times 6, that will result to 6 valence electrons. And 2 times 1 will result to 2 valence electrons, a total of 8 valence electrons. So our central atom now is the oxygen, and your hydrogen needs 2 atoms to use all 2 valence electrons. So the terminal atom all are the same. The structure is asymmetrical. And lone pair, yes, we have 2 lone pairs, or 2 pairs. And the polarity is polar. Okay, those are the first few examples. So you may take a photo on this, no? Yeah. Let's try number 3 and 4 for hydrogen cyanide and boron trifluoride. Please take a screenshot. And this is for number 5. Okay, let's check your short exercise. Okay, sige. Now, from the above example, notice that we focus on 2 things in the molecular structure using Lewis, that's structure. That is the presence of lone pair on the central atom and the different terminal atoms. Again, the presence of either of these 2 would give us polar molecule. Okay? Otherwise, it is non-polar. So how easy could it be now? Way to go, buddy. It is time to work on the succeeding activities. So this time, your task is you draw the, the Lewis, no? That structure, and you identify if there is a lone pair on the central atom, yes or no. Are there terminal atoms the same, yes or no? Or is it a polar molecule, yes or no? So number 1, we have here beryllium dichloride. Second is boron trifluoride. Number 3 is phosphorus pentachloride. Number 4 is sulfur dioxide. Number 5 is xenon difluoride. Okay? So kanilang lima, and do this in your activity notebook. Right? Finalize it. Let's proceed. Part 2. What's in the picture? So our direction is to identify the polarity and uses of the following compounds. So we have here an ammonia. So what is the use of these compounds? We need to identify its polarity. No? Is it polar or non-polar? Second one, it's carbon tetrachloride. Okay, this is our carbon tetrachloride. Third one is oxygen gas. So, kana lang tulo. Let's have part 3. Water loving or water hating. Direction is to fill in the table and identify polarity of the compounds. So we have here CH3. We identify if it is hydrophilic or hydrophobic. And then is it polar or non-polar? We have here H2O, HCl, CH4, and C3H8. Please take a screenshot. For our wrap-up activities, kindly list 5 description of a polar and a non-polar molecule. So simply, you enumerate here 1, 2, 3, 4, and 5. For the non-polar, you have 1, 2, 3, 4, and 5. And for our assignment, kindly use your activity notebook. Polarity in everyday life. How soap works. During the COVID-19 or new coronavirus disease pandemic, countries all over the world must take decisive action to stop the spread of the virus. In these critical circumstances, it is essential that everyone is informed about health risks and hazards to stay safe and healthy. One of the recommendations of the World Health Organization is washing our hands using soap. Soap does not kill germs in our hands. It removes them. Microbes stick to the oils and grease in our hands. Water alone will not remove much of the germs on our hand because water and oil do not like each other. So they will not mix. But soap likes both water and oil. So, anong ganahan man ang sabon sa water and oil? It is because soap molecules are a type of surfactant, which means they have one end that's water-loving or hydrophilic, and one end that's oil-loving or hydrophobic. So when you wash your hands with soap, the soap molecules acts as a mediator between water and oil molecules and bind with both at the same time. Then when you rinse everything off, the soap carries away the germs with water. So the first question now is, does soap remove germs and viruses? Kindly explain why. First two, why is it important to frequently wash our hands with soap and water? So let's have our post test. Which of the following is the correct structure of the compound PBr3? A structure A, B structure B, C structure C, or D structure D. Number two, how many electrons should have should carbon have around its Lewis dot structure? A 6, B 4, C 3, or D 5. Number three, which of the following substances is non-polar? AHCN, BCO2, CHCl, DSO2. And kindly read number 4 and number 5, and please answer this in your activity notebook from items 1 to 5. All right, that ends our lesson. So you can still review this lesson so that you will have a deeper grasp about um, the polarity of molecules in these topics. That would be all, and have a great day.